Hello, welcome back, Pre-Calculus. Here we are in this video on rational functions. I'm going to teach you how to find the domain of a rational function. So remember here that a rational function, sorry friends. So a rational function is a polynomial divided by another polynomial. So you could have an example of a rational function that looks like this. This is example 4 from your textbook. And this is the function f of x is equal to x plus 3 divided by x squared minus 9. So remember that the domain of a function is the set of all valid inputs. Some students think of it as all the x's. But what do we mean by valid input here? What does it mean to be a valid input? What we mean is that when I plug a value into this function, that it has a definite, defined answer. So another way you could think of a domain is everywhere on the x-axis where our function f of x is defined. And we have two actual values that are not in our domain here. So when you're trying to find the domain, sometimes it's easier to find what is not in the domain. So in our example, f of x is equal to x plus 3 over x squared minus 9. For this example here, x equals 3 and x equals negative 3 are not in the domain for f. And you can see if I try to plug in 3 into this function, that means everywhere that I see an x, I plug in 3. I get 3 plus 3 in the numerator, and then 3 squared minus 9 in the denominator. And that gives me 6 divided by 9 minus 9, which gives me 6 divided by 0. Uh-oh. We can't divide by 0. That answer would be this function is undefined. So you would say here we are undefined when x equals 3. So that's why x equal to 3 is not in the domain. And if you check, you'll see the same thing will happen when we choose negative 3. So how do you find the domain of a function then? Suppose I gave you that example and I told you, hey, you, pre-calculus student, find the domain of f of x is equal to x plus 3 divided by x squared minus 9, and give your answer in interval notation. And this is how you could go about this problem. You could say, look, I have a rational function here, and I know that whenever I divide by 0, I'm going to get a problem. Those values are not going to be in my domain. So I'm going to find, where does this denominator equal 0? Where exactly is x squared minus 9 equal to 0? And I can solve this little equation a number of ways. I'm going to choose to factor. This gives me the two linear factors, x minus 3 and x plus 3 is equal to 0. And then I can set each of these factors equal to 0. And then I get the values of x is equal to 3 and x is equal to negative 3. Now remember, what are these numbers? These are the numbers that are not in our domain. So in other words, our domain is every number except for 3 and -3. So our domain, all numbers, I'm going to say all real numbers, except for 3 and -3. In English, that's perfectly understandable. Let me show you how to put it in interval notation. So what I like to do is draw myself a little number line. You don't have to. This just helps me for interval notation. If you feel like you get interval notation just fine, you can skip ahead a little bit. But if you're still practicing your interval notation, this might help. So I think of this as number line as my little x-axis. So we get -4, -3, -2, -1, 0, 1, 2, 3, 4. And then these arrows here show that the numbers go on and on in infinity directions, all the way to -infinity and positive infinity. And the way that you write the number line like this in interval notation, this would be all the numbers from -infinity all the way to positive infinity. That's what we're talking about here on the number line with those arrows. But we want to take out 2 numbers out of our domain. There are 2 numbers that we can't use. So let's X them out. Get rid of -3, that can't be in our domain. Get rid of +3, that can't be in our domain. So now what we want to do is we want to say in interval notation, all the numbers between -infinity and -3. And we want to say all the numbers between -3 and +3. And we want to say all of the numbers between +3 and positive infinity. We don't want to include 3 and -3. That's why we have these big X's here. We're going to cut those out. And so here's how you could write this. So in blue, I'm first going to describe all the numbers between -infinity and -3. That would be here. All the numbers in between -infinity and -3. And I'm using a parenthesis here because that shows me I'm cutting out that value of -3. And then I'm going to describe the section of our number line in yellow. That goes between -3 and +3. And so that's going to describe all the numbers between -3 and +3. And then in green, from 3 all the way to positive infinity. So now I had my number line and I broke it into 3 different places. And there's one symbol I want to show you here. I'll do it in white. It's this little U symbol. It's this little U. Because we cut this value out, right? We cut out 3 and we cut out -3. This U symbol just glues together each piece of our number line again. So if you imagine that these red lines I drew through our number line, if I actually took some scissors and cut the number line here and cut the number line here so I could get rid of and cut out that -3 that causes a problem and that +3 that causes a problem, and then I would glue the number line back together using these U symbols here. And this would be your answer in interval notation. This would be your domain in interval notation for this rational function. Now here's something kind of strange. Here's something a little bit strange about our function here, is that this is what our function looks like, right? After we factored it, we ended up with f of x is x plus 3 divided by x plus 3 times x minus 3. And we found the domain of that function. I know that some of you are telling me, Sarah, just slash those little factors. We know we can do it. We want to do it. We'll get there. We're going to talk about it in the next video. But that's how you can find the domain of your rational function. Thanks, friends. I hope it was good. I'll see you in the next one.